Thanks everybody for coming. I appreciate it. Here we are. We are on our 50th webinar of this series. Been having a great time doing these. We've had just a great group of co-hosts and just tons of good information that we've been sharing. And whenever we share it with you, I learn a ton, and our co-hosts learn a ton as well. It's a great exercise. It's a win-win, certainly. What we're going to talk about today is remove all gear selection doubts is the title, and the subtitle is the gear ratio map. We've been looking forward to this, been talking with Samir for a month or so, and figuring out when we could do this, and we'll talk a little bit more about him and what he does. He runs a website called Your Data Driven, and if you haven't joined and get his emails and some of the services that he offers, you ought to do that. We'll give you plenty of opportunity to see where to do that here in just a moment. Let's go ahead and jump up one slide, and let's talk a little bit about Samir and turn it over to him and give us a little bit better idea. But gosh, again, it was probably 5 or 6 months ago. I had heard about Samir through some other folks. Maybe it was our Peter Krause or Matt Romanowski or some of the guys that I've worked with. So I joined, signed up on his mailing list, and have been getting it's about one a week, I think, right? Something like that, an email, and he can get us straightened on that. But and it's just cool things, right? It's not 100% AIM stuff, certainly, and it's but there is enough of that I found that it was interesting, and this particular topic came out maybe a month or so ago, where he used AIM software to display this. How do we figure out exactly what is the right gear position to be in, not gear ratios? That he has another process that's for that, and I'm sure he'll talk about it. But when you're in your car, you've got your set gears. How do we figure out what gear should we be in, and then how do we display it in AIM software and see if we've met that requirement while we're out on track, and where do we adjust? So we're going to talk a little bit about that from Samir from Your Data Driven. Samir, let's turn it over to you for just a minute. Let's give us the the 1 or 2 minute your background. You've got a really interesting background, worked with a ton of different people, and smart guy, professional, and give us an idea of what you do, and then your racing background, and a little bit of what you do with AIM.
Yeah. Thanks, Roger. The flattery is a good start. Thank you. Yeah, so I'm an engineer by training. I've worked in automotive as a vehicle dynamicist and suspension guy for. That was the first period of my career for about 10 years, working for Aston Martin, Jaguar Land Rover, and also some race car stuff. So I worked for a company called Multimatic, which is a Canadian company, which many people will probably have heard of. So very big in racing, and yeah, you can see here some of the cars I've worked on. Then I took an opportunity to step out of engineering for a bit when I did a bit of an MBA, and then a friend of mine from Formula One moved into the world of Olympic sport, and he said to me, Olympic sport, this is about 2010, something like that. And he said, it's getting more technical, but they don't have the expertise. And so then, yeah, I've been working in Olympic sport for the last 10 years with all the Olympic teams. It's built a bit of a consultancy there, helping them with their data and decision making, building tools and helping interpret data and make them jump higher and faster, train more efficiently. So that's the last sort of body of the last sort of 20 years or so. But all that time I've been racing as well as a club racer. So I've got my professional hat as an engineer, and then I've got I'm a club racer too. So I haven't got a team of people around me. How do I switch from being the engineer, the mechanic, and the driver, and the guy who tows the car around? So I've got an affinity for both sides of the coin, as it were. So I set up Your Data Driven about 9 months ago to start sharing some of that knowledge and trying to help people out with the challenges that I have as a club racer, and my other friends have club racing, to try and maybe distill some of the myths that you hear about in the paddock, and to say there is actually an answer for that. And in this case, there's quite a nice thing about gearing. You just hear about is that a third or fourth gear corner? We'll talk about it in a minute, but and then there's all sorts of how can you say paddock wisdom that people will give you, and you know that, but it's not necessarily right. So you can actually work it out, and I'll show you a method for doing that. And I can, you know, we can go through that. But you know, the nice thing is there is some certainty in this. So if you're looking to lower your lap time, this is how the professionals do it. And you know, so the whole thing about your data driven is it helps you with that. I mean, I've got a podcast now, and as part of the thing, so we talk about things every week, and you know, spreadsheets and courses, and there's loads of stuff on there. But you know, in general, it's about helping you reduce your lap time.
It's interesting, not to go into the story deeply now, but you've shared a couple of stories of things you've done in the past, and one of them being, gosh, a runner, you know, in a marathon, and helping them select the right lines for the slope of the road, and all of that, and using virtually the same exact thing that we do in our motorsports side, right? And looking at time loss or gain because of certain things. And it's just intriguing that to me that engineering in speed and distance and the things we do, you go across to many different platforms. It's kind of interesting.
They go across everything. I mean, that was a fascinating project. So I worked on that project where last year Eliud Kipchoge was the first person to run under 2 hours for a marathon distance, and we went full engineering on it. So we looked at aerodynamics, we looked at weather, we looked at the running line, and we actually LiDAR scanned the whole track like you do for your race games, you know. And then so my job was effectively what we would call in motorsports. I had to work out the racing line for him to run around this track so that it was the most efficient use of energy. It's fascinating.
Yeah,
but
amazing.
It's all stuff that you guys would be familiar with, but those guys had no clue about. So it was great.
Very, very interesting. Look forward to chatting maybe a little bit more about that specific thing and how that works into a motorsports thing. So I appreciate you being here, and we're gonna have a good time. And the topic we're going to talk about today is gear ratios, right? Or not gear ratios, but gear position. Kind of you have a little bit of information on both, but are you in the right gear, and did you get there at the right time, and is it faster or is it not? And there's a little bit of work done ahead of it, and recently, and I shared this with you as well. A couple of weeks ago, I mentioned a spreadsheet that I had some in my stuff that I'd gotten from some engineering folks, and it does similar to what you're going to talk about today. So some of you, if you've gotten that from me, you have it. Samir's is actually much more robust, and it does even quite a bit more. Mine is when you figure out your rear wheel torques and where it crosses over, which we'll talk about in a moment. On the one that I have, you actually have to kind of dig in and find that, and some of the stuff that Samir's done has made that a little bit easier for you. So there might be a good reason for you to chat with Samir and get his. So let's talk a little bit about this. Let's step up to the first slide, and kind of turn it over to you, but I'll kind of start it with this first slide a little bit. But gear selection doubts is what we're going to call it. Is that a third gear or fourth gear corner? When are you changing up? When is the best RPM to change gear? Questions like you mentioned earlier. That paddock discussion happens all the time, and people are so correct, or so vocal about what they know, even if what they know may not be exactly correct. And so sometimes you hear, well, yeah, when you're in this, let's use a class that's pretty popular around here that everybody has a lot of the same gear ratios, obviously, is maybe it's Spec Miata, and you're talking about a corner, and no, I roll through that in fourth, and no, I roll through that in third, and well, really, what is the best place to be, right? So with that, let me turn it over to you. I'll run the slides. You just let me know when we want to move to the next slide, and let's turn it over and let you kind of explain the process, and then we'll get it all the way to the end where we end up in Race Studio 2 looking at some data where you've done what we're going to talk about. Okay, that's where we're going to head today, folks. So go ahead and take over, Samir, and let's see where we go.
Absolutely. So yeah, this is like I say, a really common question that I hear all the time, and it's sort of, well, is that corner a third or fourth gear corner? And when should I be changing up? So should I change up at the rev limit? Should I change up on the red line? Should I change up at peak power, peak torque? Should I change up when it feels right? The car will tell you to change up. There's all this wisdom that goes there and says, well, this, and is it the same in each gear or is it different in each gear? And there's a lot of help, but it doesn't necessarily answer the question with certainty. And equally, flipping it the other way, something that's even harder to work out is when to change down. So you're going into a corner, it's like, should I change into third or should I change into second? And would I be better off in that lower gear or should I stay in the gear I'm already in? And again, you're working with like feel metrics as a driver all the time, and that kind of gets you so far. But if you had no doubt about whether to change up or down, surely that's going to be better. And there is a way to work it out, and that's what we're going to go through. And it's what all the professional teams do, and they program the dash. If you can do that, I think the aim products, you can do that as well. And you just remove one element of having to think as a driver. You just know, right? Okay, I know what gear to be in. Now there are some caveats to that. Just to say, there are some caveats to the theory. Okay, and this goes for all data. You have to take that pragmatic approach to it. So, and as we'll see in a minute, it's going to say, do a down change. But you might decide as a driver or as your team, you're like, that down change isn't practical because I'm on a corner or I'm mid corner or I'm about to, I only dip down and I'm straight back up again. So what this thing will do, will give you like the ideal gear to be in if you had a seamless shift box that had no impact on your rear axle torque and it didn't unsell the car, okay? But it still gives you that certainty to then make a much more informed and educated choice about what gear to select at any point during the lap. And that's really what we're trying to do. So I just want to frame that. So there's like the theory, the data and everything, but also that, okay, that's only just going to help us make a much more informed choice, but we still make our own choice. Okay, so that's a really important point, I think.
That always is, that always is an important point. Sometimes we get so deeply into the math and we think that, okay, and we can calculate things nowadays so accurately and so clear that that we forget the reality of it all, right? It's that is over the top of a hill and off camber. And boy, if I upshifted there for just a second, it would just, it definitely would slow us down. So you obviously at the end of the day, you need to put it into practice and what works. And then the bottom line there is it's two of our money channels, right? Lap times and speed. So this is getting you close, and then boy, did it help the speed go higher, and did it help the lap time go lower? That's what at the end of the day, you're trying to make sure that those two things work on top of it.
Yeah, absolutely. So that's the problem. So if you click on the next slide,
let me see if I can get it to go. There we go. Okay.
So basically, in summary, the best gear will give you the fastest acceleration, which is the lowest possible lap time. If you're not in, so just think that through. If you're not in the right gear, you'll be going slower than you could be. Yeah, that's all. It boils down to that.
There you go.
And we're racing. We want to lower our lap time, so we want to go as quickly as possible. And the nice thing about gears, actually, it's quite a low skill requirement. So it's not like trail braking into a corner and all that feel. It's literally just putting the car in the right gear, and you're getting free lap time. So it's worth having a look at it.
Certainly doesn't cost you anything, right? It's not like buying a motor with more horsepower. It doesn't cost you anything.
So go for the next slide, and then that summarizes what I just said there. So on the next slide, we've got basically this. I'm going to split this into two bits. We'll do. We go on the next one, Roger. Yeah, that's it. So, like, is there a best? I've just sort of introduced it. Yeah. So, is there a best gear to be in? Yes. If so, how do you work it out? So, we'll do a little bit on that, and then step 2 will be, okay, well, I know now what gear to be in. So what? That's no good. I'm out on the track, or I'm back analysing my data. How do I actually apply some of this knowledge? So that's what we'll cover in step 2 and try and make it a bit more useful.
Perfect.
So go on then. Yeah, yes, there is a best gear to be in. Right, let's go. So you only need 3 bits of information for this. So if you click on the next one, which, if I'm honest with you, when I first looked at this, it surprised me that I didn't need more information. I thought I might need aerodynamics, and I thought I need like all sorts of different things. But When you look into it, there are only 3 bits of information you need. You need your torque curve from the dyno, which most people have, or you can get one if you're in a spec series or whatever. Your gearing, which is normally pretty available, so your gear ratios and your final drive, and the tyre size. And the reason the tyre size is important is if you think about the torque coming from the engine and then it goes all the way through your gear train. And what we're looking at here is to maximize the amount of force you have applied at the contact patch at any particular speed. So the size of your wheel makes a difference here, okay, in terms of working this out.
But I had a question the other day, Samir. Samir, I had a question the other day that that I thought was interesting, and I answered in a certain way. So hopefully I'm right. When you horsepower torque curves, the torque is what you're looking for here. Would that matter if it was from a chassis dyno or an engine dyno?
What I'm looking at here is the torque of the wheels, but you can use both. You can use both, but it's better to use the one that's at the wheel for this particular exercise. So,
so the numbers may be a little. The numbers will be different because
I want to say no, it doesn't.
Yeah,
I want to say no, it doesn't matter, but
and mainly because of the difference between 15 and 2000 and 2000 and 2500. When it goes through the entire process, it's going to show you where the right spot to shift, no matter what. Is what the way I at least thought of it.
I mean, because if it's at the wheel, you're kind of baking in the losses, and you don't have to worry about them anymore and stuff like that. Yeah, so, okay. But you just work with what you've got.
Perfect.
Okay, so the next slide. What you get, I hope everyone can see that okay, but basically, so we've got this is a 5-speed box, and it's a Mazda engine vehicle. Everyone's fans of Mazdas, so why not? And so what you can see here on the y-axis is the torque, and then on the x-axis is speed. In this case, it's speed in miles per hour. And so just look at the curve, or the curves. Hopefully your mind will already be doing some pattern spotting and stuff like that. But if you think about how that feels, okay, so that first curve that you've got your mouse, so that's first gear, okay. And you just think about how your car drives in first gear. Let's get the intuitive bit going here, right? So you're just in first gear and you start off and you have a lot of thrust coming up. So you're going forward, accelerating really quickly from 0, and then it tails off a bit, and then you get to the rev limiter, or you run out of revs in your engine, and you just can't go any faster. Okay, so that is what's going on here. Compared to if you started off in 5th gear, which is the bottom one, you can imagine it's going to be a lot more laboured to start with, and you're going along, it's laboured. Eventually you get up to speed, you know, we're going to get there, and then you end up topping out at a much, much higher speed. Okay, so that is what this chart is kind of, that's the feeling that this chart is effectively, when you look at this chart, that's the feeling you should have, right? But what we're really interested in is the amount of torque. So if you can get more torque in another gear, you want to be in the other gear. But until you can't get any more torque, and this is at the wheels, remember, all the way down there, until you can't get that, you want to stay in the gear you're at, okay? And so to answer that sort of the folklore thing, you know, max peak power, blah, 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 it's all kind of irrelevant. It's when you can get more torque in another gear is when you want to change. And if you click on the next slide, I've done exactly what you're doing with the mouse there. And what you're saying is where those lines intersect, so first gear intersects with second gear, that is the speed you want to change. And where second intersects with third, that is the speed you want to change. And so what's actually nice is that, and again, when I first did this, it was like, oh, that's really resolved into something quite nice, is in the fact that for any speed, there is just one best gear for you to be in. And if you think about that simplifies everything. It simplifies everything. There's no like, oh, well, it's about the rev matching and I've got to do this. It's nothing to do with that. For a given speed, there is an optimum gear for you to be in to get the most acceleration going forward.
Yeah, based on your engine output, your gearing, your tire size, and all that, there is this one spot that one gear to be in at a certain speed. That's interesting.
Yeah. So, and this is the theory anyway. Okay, so this is and so in order to simplify it all, we work through that. So on the next slide we have. So I've got this like little spreadsheet and it produces this. I'll give you a link in a minute, but or Roger will give you the link to it somewhere. But the spreadsheet, my one, it works out all the intersections, and then you get a little table like this. So it tells you what RPM to change and what speed that is the equivalent to, and you get these little this little chart at the bottom here, which is the rev drops, we call it. But what you can see in this particular engine, this particular example, that the RPM. The change RPM in first is 7,786, but the RPM change in second gear, from second to third, is just over 7,000. Can you see that? So you get second, that's from first to second, and then if you go through second gear, you'll go up, that's it, you'll go up to there. But that's not 7,000, it's not the same number, because it's changing at a different point, and the intersection's at a different point. So that's why it becomes a little bit scientific, but you can then just put those RPM numbers on. I've done it like that in the little thing, so you can cut it out and put it on the steering wheel if you want. Or if you have a programmable dash with the lights, you can set them so that, you know, the lights.
And you mentioned that a little bit earlier, and all of the current generation of AIM equipment, we can do a gear specific shift lights. So the older stuff, no, but the newer stuff, absolutely yes. And even when I first found this, when we were racing Spec Miata and MX5 Cup, when this was a very true statement, what we're looking at here, I ended up saying, you know, to the driver, because we had an MXL at the time, we couldn't do that, but so it was in, you know, in second gear, you know, you went to the red light and then each light back, and so he would shift a little bit earlier each time and one less light, depending on the gear that he was in. So we made it work for us. But all of the new stuff now has that. The only other thing I want to add as before we continue on is this presentation will be made available to you. I haven't not looked down here, but the presentation will be made available to you in the YouTube description box. I will, as soon as we get done here, we always put the video up, and down in the description box there will be a link to this as a PDF file. Brick, and again, just before you get started, Brick is the link master today over in the chat box. He is the gear ratio map accompanying article. He has put a link into the chat box for those of you that are watching this live and you'd like to click on that. We will have those links in the description of the YouTube video as well. So thank you very much. Samir, let's continue on.
Yeah, I mean, the idea of the links really is just to explain it in a little bit more detail.
Yeah.
I'm sort of skipping over some of the stuff here, and I appreciate that.
We only do have an hour, so it's obviously we can't dig into all of the engineering of it, sadly, but because I would kind of like to, but it is what it is. So.
But it's one of those things, like, so if we take it on faith that what I'm saying has some merit to it, it does have some holes to it as well, I'll be honest with you. But you know, it has some logic that you can go and find at the link, right? But assuming that it's right, yeah, assuming that it has some value and it's great, you've worked your way through either my spreadsheet or you worked it out for yourself, and you've got a little table like that, and it says, right, you know, that is for any given speed, you know, I know what gear I should be in. Okay, you've done the work. So the next thing really is like, how do you do anything with that? Because that's like kind of a nice engineering tabletop exercise to do, but then you want to go out in the car and actually apply it. And I certainly don't know the difference between 43.1 and 43.2 miles an hour. So how do we actually apply that? So if we go to the next one, the next slide, we've got we can get into the things. So we've worked it out, tipped it. Yeah. Okay. So next slide. Making a gear ratio map in aim.studio. So basically what, again, I've seen quite often in a professional level, but also you can do it here, is to help the driver out by giving them a map of the track, like a track map that you're used to, but then color coding it by saying what gear you should be in. And it's a bit like if you've ever done like your own track map, and you normally like put a big arrow, so like that's third or that's second or whatever. What we're doing here is we're using that philosophy of like, well, we now know what gear we should be in because we just worked it out, right? So we know what gear we should be in, so we can put that in to the AIM Studio using a little math channel and plot it on the track map, and then have a look and actually see, right, okay, we basically get the AIM Studio stuff to do it for us. Plus, if you have one of the loggers that records your gear position as well, I don't know if they're all automated or whether they do it on speed or whatever, but if you can get your gear position as well, you can then compare what gear you were in compared to what you theoretically should be in, and then that's really useful. Okay, so that's what we're going to do now.
As we kind of roll, let me go to the next slide. But there's a question we had there from Harry that I'd like to touch on while I start a poll. Read that question if you can, there, Samir. I'm going to start a poll. We like to do these polls. It really does help us out. Let me launch this poll. Who do you compare data with when all of us that are watching here today, who do we compare data with? Do you, it's multiple choice. So if you do 2 or 3 of these different things, please let us know. The question from Harry is what about torque above 52 RPM? And there's a distinction here that we're actually talking about here is we're not talking about where horsepower and torque cross over and all of that, like on an engine dyno. What we're talking about is that rear wheel torque, that rotational spinning torque of where the rubber meets the road. So with that said, and you please answer from an engineering standpoint, Samir, and somebody way smarter than I think that particular number, which we do calculate horsepower and torque with, is not used in the discussion that we're having today.
I think if I'm guessing, I think what Harry is alluding to is that in 4th gear into 5th, it just sort of, that little chart just stops. I'm guessing that's what he's seen. And basically, it's a 5-speed box, so anything above that particular thing, you just stay in 5th. So,
yeah. I remember looking at your chart, and it said, that Miata, that Mazda data that you were using, it said it would go to like 178 miles per hour, and no Mazda. I've had some decently fast Mazdas, and not one of them would ever go that fast. So, but thanks everybody for doing the poll. I'm going to go ahead and end it here in just a second, and then we'll share the results and we'll take a look at it. So let's end those results.
We got another question there from Tim. Do you want to do that one quickly?
Let me show this, and then let's go ahead and do that.
Wow.
There's your results of who do you compare data with, and the YouTube audience doesn't get to see these, so I try to call out the top ones. But so 1 or 2 friends / teammates was our number 1 result. 59% of the group that voted. Number 2 was only with myself. A lot of guys, they're at the track with and they look at their data and just and need tools, one of which you're sharing with us and teaching us about today, of how they can just look at something and use the data. That was 52% compared to 59 on the top, and then the other 4 were substantially lower, with the pro for a data lap being right there at 7% in 3rd. So a big thing.
More than one thing.
Yeah, and it was multiple choice, so they could select. So many of them are clearly looking at their data themselves, and also sharing it with teammates or friends. So I'll stop sharing those results, and then let's talk about that question. The next question in the Q&A box: can you please provide information to add 6th gear by explanation or enhancements to the gear calculator spreadsheet? I think some of yours give us only 5 gear positions, something like that. Yeah, how would you work around that, or can we add a 6th gear?
I'll be honest with you, I've got there's 2 versions. I added a 6th gear in the other one, in the other version. It's the same philosophy though. Each one adds up, and you can use the same spreadsheet for 6th gear. So there's 2 ways to do it. You either use my other spreadsheet with the 6th gear, or you can kind of work out the gear change positions for 1 to 5, and then shift them all up, and then pretend, forget about 1st, and then do it again for up to 6. That's another way around it. It's a bit of a faff, but
and I agree. I agree with you. There are if you've got a 6-speed, my guess is that first gear is leaving the pit lane, and in most production-based cars, first gear is everyone that I've ever ran out. It hits the rev limiter before the torque number is before second gear is better, and so what I would do if I found myself in that position is just do second through sixth, and leave first to the number one. You probably don't use it on track, but even if you do, it's probably is at the rev limiter for the.
Well, it's kind of just to sort of not to derail the things and get too geeky straight away, but the first gear thing, there is another element to this when you talk about the wheel spin and stuff like that. So it's important to know where you're at with that, and the other spreadsheet. So today we're talking about optimizing the gear change timing and like making sure that you're using the best with what you have. But if you can change your ratios and your diff, then that's where the other spreadsheet comes in, and you can start to optimize. Or if I can change my diff, what should I put? But that's a story for another day, and you can grab all that stuff. Now, I don't want to like spend this whole thing promoting my own stuff, right? But that's another question, different question. But today's about like what shift points, and let's get that bit right. But there is a whole thing about gearing, about, well, what gear should I use, and if I've got 6 gears.
Very, very, very complex when it gets down to it, right?
How it all works, and it's not super complicated. Really, it just takes a bit more time to work through. So,
Brick just listed a link for in the chat box. Choosing the best gear ratios for racing cars. So it's what you just chatted about. If anybody wants to learn a little bit about it, click on that, and it takes you over the page. Again, it will be in the description box of the YouTube video later as well. So.
Yeah, it's a big topic.
It's back to what you said a few minutes ago, which a light bulb went on for me. There are things that cost money to go faster, and there are things that you can just learn to help you go faster. This is one of those that it's a free, dollar-wise, things to tweak and understand, and understand your car better, and make it as fast as you can make it. It's a very important thing. So. Perfect.
So let's have a look in AIM Studio. I'm going to use a slightly different example. So the one I showed you a minute ago was a 5-speed. And sorry, Tim, we're going to go to a 4-speed now. But to make it just a little bit more simple. Now so we're going to take some real data and then basically work through the outcome, and then show you what it looks like in AIM Studio. So here we go. I've worked through on the top right here, and it's like I've got a 4-speed box, and they are done all my calculations. I've put my torque curve in, my gear ratios, and my wheel size, and it's told me they are the speeds to change. Now, just to really re-emphasize what this means, I've created this little line at the bottom, this little chart. So if you've just literally got MPH along the bottom, and up to 28.1, you're in first. Above 28.1 and up to 52, you're in second. Over 52, up to 74.8, you're in third, and above 74.8, you're in fourth. Okay, just to really just clarify that there is no overlap. At these speeds, you want to be in those gears, and that's it.
For the maximum driven rotational force of that tire patch with your package.
Yeah. So it's actually just to sort of flip that. So if you're doing a speed and you're not in the recommended gear, you could be going quicker by being in the different gear. Okay. So if you go to the next slide. So so that's that chart again, and so basically if I wrote out in words what I've just said to you, it's like if the speed is less than 28.1, being first. And the reason I'm doing this is because this is how we get to the math channel, right? I'm not sure how familiar people are with if statements and writing equations and spreadsheets and things like that. And so I thought, well, if I wrote it out like this, hopefully it will make it really, really, really super clear. So if the speed is less than 28.1, we're in first. Boom. If it's greater than or equal to 28.1 but less than 52 in second, greater than or equal to 52 but less than 74 in third, and if it's greater than 74 in fourth. Okay, so sorry if I've laboured that twice.
Not a big deal, because we're building up to an if math channel, which Brick may have a chance to link that. But we did a video maybe 2 or 3 weeks ago where we talked about exactly where you're going to go, and I know a lot of people watched that. And what you just spelled out is some things that we've actually talked about in the past, and
Cool.
we'll put a link of that YouTube in the chat box as well as in the description box below. So we'll see what that math channel looks like in just a second.
So if you pop the next one, so that's the math channel. It looks awful, doesn't it?
Yeah, no.
They do. They look really scary. It's like, and it's a nested if statement for the geeks out there. And like, so if you just click on the next one, right? So this bit of it is the equivalent to less than 28.1, and you can see like LT in the AIM math channel language stands for less than, yeah, LT. So if brackets something which is less than, and what is less than? Well, the speed, in this case I've used GPS speed, which is the normal channel you get on your logger, is less than 28.1. Do something. Well, I want it to say 1. Yeah. Okay, so that's what that says.
And Brick now has linked to that video that Ray Phillips did with us a few weeks ago, where he broke down these nested if statements as well. So while Samir is going to go through a little bit of this, if you want even more detail, click on that link, and you can learn exactly how it's broken down as well. So perfect.
They're just really awkward, aren't they, with the commas and brackets and you faff around. But there is a nice thing actually. I do quite like the feature in AIM where you can check your equation. That is quite a nice. That's quite a nice touch. Okay, so this is the next one, which is, you know, if so the question is, well, the first one was if the speed was less than 28.1, do 1. Okay, well, so we're doing 30 miles an hour. Now what happens? Right, we move to the next chunk, which is you can either say 2, or you could say I have another if statement, which is why it's nested, and you say, right, if again less than GPS speed 52. And the reason you just say less than is because if we're into this bit, it's going to be already above 28.1. Forgive me if this is like really, really obvious to everyone. But I just want to make sure how that works, because in my written thing, I've said greater than or equal to, but there's no greater than or equal to in the math channel, is there? But it's implied by the fact that because it's above 28.1, it is greater than or equal to. Do you see what I mean? So anyway, so that's, if it's less than 52, we're in second. If you go to the next one, we're in third. You've got the little 3. And then above 74, we don't have to write greater than 74. We just have to say, and if it's not any of those, put it into fourth. Or put fourth. So that's how the math channel works. That's the logic of it anyway.
Let's talk a couple of questions. I think that's a pretty good explanation. Bruce mentions, can longitudinal G-graphs in each gear help determine the proper gear? I'll take a crack at that first. The answer to that is in some way yes, but there's what the only downside of that is that's the end result, and maybe there is some slope of the road, or maybe your car it doesn't accelerate super well like a lower horsepower sports car or something, and then the longitudinal thing can become hard to read, where this is more of an engineering answer to that. So yes, you can do the other one with longitudinal G and feel, and that's what you're feeling in the car that Samir talked about before, where the car is telling you, right? When you have accelerated so far that it's starting to lay over, or have drop the nose, a lot of terms people use for that, then it's time to shift. This is just giving it to you before you actually feel it or see it in those longitudinal Gs. So if I could
add a bit to that one, Roger, it's with the longitudinal G, you can see the step, you can see it going down. So in a lower gear, you'll be accelerating more, and then it goes down. And you can see, like first to second, you can see like a step sometimes if you get it wrong. Depends on the quality and how much you zoom in the longitudinal G, but you can actually see it.
Yeah.
So it does help, but you want to be coming at it from this end and then double checking it with that, rather than looking at that and going, you know what, I should have been in a different gear. more
Certainly.
intuitively. I mean, that was my thought.
Yeah, me too. I happen to agree with that. I used to only use the longitudinal G method until I found this, and I found this to be much more accurate and much more proactive, right? You know it ahead of time. The next one, when optimal shift point is near the red line, how would you weigh the potential or bigger time loss of bouncing the rev limiter versus shifting a little early? Samir talked about that earlier. That this is engineering, this is mechanical, this is what where you will get your best acceleration, but it's not always perfect. The track always will throw some things at you. How long does it take you to actually shift and then back downshift for that half a second of time that you might be at or near the rev limiter or beyond that point? At that point, it does come down to data. It comes down to doing 3 or 4 laps one way, 3 or 4 laps the other way, and look at it and see what how the money channels have either improved or got worse, speed and lap time. So it's not always perfect, but this gives you a good shot at it.
And just to jump in again, sorry, on that one, it's just I would go a little bit shorter, like you were saying. Yeah, so don't bounce off the rev limiter. Go change a bit earlier. But so if you can do this, particularly with some variable valve engines, whatever, where basically you do this and it just says go to the red line every time. But the value becomes then on the down change, because the down change is very, very rarely the same RPM unless you've actually altered the gear ratios to make it that way. Okay, so it doesn't become about the up change; it becomes about the down change.
Yeah, and Andy talks about what if there's a turn with a minimum speed of 50 and you've got a 52 at the peak. That is, again, one of those things you just got to try it and see where it works. And if a downshift upsets the car in a corner, it's not worth it at that point, right? So then you roll through, right? We're going to actually see some examples of that in the AIM data, I think. Okay. Do you need to dyno in every gear, or just the normal fourth or 1-to-1 gear? Just the normal way. What you're looking for is the torque difference between each RPM, so we can actually chart it. So no, you do not need to dyno in every gear. Okay, Brian, thank you very much. Okay, let's jump to the next one, and where you can kind of explain to now we're starting to put it in place, right? Now we've built the actual gear ratio of gear position of what you did while you were out driving, looking at the slide, and we've got this ideal gear that we have just created the math channel for with those nested if statements. And then you can start to look at it. We'll look at this in some real data here in a moment, but I just wanted to kind of start to introduce what it's going to look like in the AIM data, right?
Yeah, that's it. So this is the real thing. Which we'll go through in a minute. But yeah, so you've got the actual gear of what the driver did, and then the ideal gear. And linking back to that question we just had a second ago, you can see it's like earlier in the lap, it's saying, should you be in third or second for about like a meter or something.
Exactly.
And it's like, well, just ignore it basically, or drive a bit quicker,
or get to the point or put a taller tire on it, or something, right?
I don't want to go all sort of driver coaching on you, but you know what I mean. It's like if that's happening, it's like drive a bit quicker.
It's all linked together, right?
It is, yeah. You can't really see those, can you? I think it'll be better in the real thing. But basically they're 2 track maps and they're color coded. One is the ideal and one is the actual, and it's just a nice way of visualizing it. And you can see, okay, because it's on a track map, if you go all the way to the beginning of this conversation, but we normally draw the track map out and put big arrows and say that's second gear corner. Well, this does it for you. So
we'll study, especially this corner here in the data here in just a moment. Is what the one that I found that was kind of interesting was this. You can see here in the ideal it says the downshift, and over here the driver did not. We'll take a look at that closely. So,
okay.
Sherm had a question that I don't necessarily understand fully, so you might be seeing it already. But since shift lights are based on RPM, can one base the MC on RPM versus speed? The MC, I'm not sure exactly what he means by that. The chart, I assume, the math chart, the math channel on RPM versus speed instead. Your whole process is built on where is the speed, because that's where most of us think about, and you're not changing your gear ratio, so the speed ends up being a valid point to use. But it can't be on RPM, because you could be in the wrong gear, and the RPM would be at multiple RPMs at the same speed, right? Depending on which gear you're in. So speed is probably the best way to do this.
Yeah, if you just think that through, yeah. So The answer is no, because you can be at different RPM at different speeds, and so it doesn't work because you've got the gear. So what this is doing is trying to simplify it. So say like at 50 miles an hour, you're in second.
It is the best, engineering wise, mathematically wise. It is the best, and if you want to be into something different, there may be good reasons to do that, but it's up to you to figure that out at that point, right? But we're giving you the ideal, not necessarily the best. Your title here on the page we're looking at, ideal, maybe not the best, right? Maybe you figure out a better way to roll through that, right? But as of right now, with your stuff, ideal.
Ideal in the sense of flat track, no corners. No seamless shift.
Yeah, acceleration.
So there's no delay up or down in gear shifting. No time cost in that. There's no corners and there's no hills.
So we got to then actually put it into real life, right?
Yeah.
And that's what we're going to do next with our race studio analysis. Let me do a new share. I think we got all the questions handled a little bit. So let's jump into that same data file. And we've got it here now. So we got about 7-8 minutes to chat about what we're seeing here. Where would you like to go? Do you want to go look at the math channel first? Do you want to just look at the data, the resulting? Where do we want to go, Samir?
As we haven't really seen the map, can you change the color code? So that color code there is the ideal one, isn't it?
It is. Okay. Yep.
And so you've got the different colors. So you've got like second gear. So remember, it's a 4-speed box. So you've got like the second gear, third gear, fourth gear, and it's not in first. So basically anywhere and that's the nice thing actually. Yeah, when you set it up, you can mouse over it and it tells you what gear it's in. And I just thought that was like a really nice touch in case you forgot the color or whatever. Yeah. And so, but then if you compare that to if you go to like change the measures for that chart.
Okay, so we can come in here and we can put it into the actual gear, right? The gear that the driver actually was, and now you can see what the driver actually did. It certainly didn't downshift in this corner here, right? Exactly, and we can see that in the data here, and we can see that in the map.
So so this is the bit. So there's two things here. There's like what is the ideal saying, and then what did I do as a driver, and then from what the ideal was saying, what recommendations should I adopt from the ideal to then change my behavior on track, to change my gear shift sequencing so that I can go quicker. And so that's basically what we're going to do here. But you can do it in the charts. And then at the bottom one here is the difference. The bottom chart is the ideal minus the real. Yeah. So where the line isn't 0, there's a difference, and then so you go, right, okay, well, what's the difference? And do I ignore it or do I adopt it?
Yeah. So you get that option. We could even colorize this map.
Yeah, do switch it back
with the difference, right? So then gear difference and apply an exit. So now wherever it's red is it thinks or not green. This way you should have been one lower, right? And we're in that area over here where your ideal said we should have been in second, and yet the driver went to first, right? So up one here, but then there's other spots where the driver was in third. The math says maybe you should have tried second, and it's showing us in red in areas, especially this corner. This is the one that probably of all of them that caught my eye. It's more or less the longest one, right? So there's a couple other that are there, but this is a long one, and it's leading onto a straightaway. All of these make this one to me to be one important one.
Yeah. Do you know the track?
I do not. Nope.
Yeah. So this track's called Cadwell Park in the UK, and it's has a reputation for being the UK Nürburgring.
Yeah.
It's very, very narrow. And this particular bit of the track, it sort of goes right and then right where the red bit is, and it's over a crest, a blind crest, and then it's off camber all the way down the hill.
Oh, okay.
And so this is a great example of the data sort of saying this is an obvious change, and the driver would probably swear at you.
No, it's off camber downhill. No, I am not. This will not work if I do that, right?
They might do. It's early enough. If you look at it, it's early enough in the corner. Like so if it was any further in, maybe not. But it just
really falls off.
I would, if I was advising the driver again, I'd say that you can probably you go off on all the other metrics and look at, grip and things like that. But, it might be that he might, rather than the down change, we might prioritize him, like, how can we carry more speed with that corner, to be honest, because that's going to be quite a complicated effort to down change. And he's changing up again pretty soon at the exit.
Yeah.
One of the ones that is quite interesting, flipping it the other way, is if you go around, to where your mouse is there, that one. So that's quite an interesting change, because again, it's telling you to drop down on the way into the corner, and then you're coming out on the way out. But in that particular corner, I think you could probably do that, to be honest. Again, you just need to know the track. And it was like, I wouldn't have thought of doing that unless I'd seen it. So you're like, okay.
Perfect. So again, what's interesting about this is it gives you the opportunity to have your engineer on board with math channels and calculating some things up for you and giving you some suggestions. It's not saying that this is absolutely the best thing to do, but absolutely, I just love it when you can find some things, some tools to be able to look at it and go, you know what, for my setup, with my gearing, with my tires and my car and the engine power torque curves that I have, this would be an ideal thing. Try it, and if it doesn't work, it doesn't work, right? And if it does, you've probably just gained 3 or 4 tenths, and it was free, right? So dollar wise, it was free. Invested some time.
There's one here it's a slightly different angle, right? So if you go to the
about what number of feet?
Back.
Where are you looking down here?
2,000, something like that.
2,000?
Yeah, something. No, there's a bit further back. Yeah, see, there's that little one there.
Okay.
Right. And if you move it so that the guys can see it, it's like a little bit of red. On the straight.
Right there.
Yeah?
Okay.
And what that's telling you is that he's not changed up at the right time.
Okay.
And that's quite valuable. So you think about yourself going in a straight line. Do I rev it off the limiter like we had the question, or do I change up? When do I change up? And he's changed up.
He's changed up early, and it's left a little on the table. Yeah. The math tells you that. And then if you use our delta function, we come back in here, and if we measure here where the driver actually shifted versus where the programming is telling us, it was about 67 feet, or only about 6/10, but there is time and speed left on the table, right? It's free time. It's in a straight line. We can really hang our hat that this really is the right thing to do, right? Because of the math. Perfect. Good example. Okay, perfect. And there's a little bit of the downshift is telling us the same thing. Again, the downshift is an area where I probably wouldn't do a ton of it there.
To be honest, I think that's quite good.
Yeah. It's pretty darn small, right? Pretty darn small. Yeah. So,
I wouldn't be too worried about that one. Yeah, I think that's pretty good.
There was an interesting chat just a little bit ago. Let me go back to it. Tim put a point up that, and the question was a lap integral math channel showing how much time spent in the wrong gear could be interesting. It might be again, it's an exercise, I suppose, and we could figure out exactly how much time that between the two. And then as you went back out and maybe tried to make an adjustment, you could see if you've made that bigger or smaller. That might be a fun thing to do. Ray Phillips, the fellow who presented the data on the if nesting and the power of if was the name of the math channel. He also jumped in there and mentioned showing the GPS slope would probably help determining that gear as well. And more data, right? What happened? Where did it happen? Why did it happen? That why piece. There's a number of things we might want to look at to understand if it's why we might want to do these things. So all good.
I think one of the things. So for me, it's about creating structured conversations that are based on reality and not based on feel. Okay, so if we roll all the way back to the beginning of the problem, is it a third or fourth gear corner? You're going to get opinion and feel, and you're going to get direction, and you're going to try different things. So all we're trying to do with all of this stuff, all the data, is just to reduce the level of guesswork and increase the level of certainty so that you still have to go out and make your own decision, right? But at least you're basing it on something a little bit with a bit more depth and a bit more objectivity and a bit more rigor. That's all we're trying to do here. It's not ideal, right? But it is giving you some structured thought process and structured conversations to have. And you could ignore it. You said, oh, that's no good or whatever. But at least you're doing it from a base of solid information.
Certainly.
It's my thought.
And I happen to agree with that, and I think most people here do too. They enjoy their data, so that they want good, enforceable information that they can just, instead of somebody telling them something, which is valuable too. But here you can actually work it out. There's a couple of questions here. I'm gonna start a poll as we're kind of start to wind this up. There's a couple of questions that are in the Q&A box, but I'm going to start a poll while we answer those, and let's launch this poll. Many of you look at the data at the end of the day. What do you look for or look at or look for? There's a poll there. It's multiple choice. What kind of things are you looking for? And I think that might be interesting with the topic that we have today. While they're taking that poll, Samir, we already mentioned this a little bit, but Johan, are you using the same data for optimal downshift during braking? We chatted about that a little bit, where that's a little bit, when you're downshifting, it's a little bit of a different math problem, right? I think you mentioned that earlier.
Kind of. It's like, if there's just let's like reiterate that for any speed, there's an ideal gear to be in. For
acceleration, not deceleration, though.
Yeah, but then okay, so that's a good point. Yeah, so are you using it to help you with slowing down for the corner?
There you go.
Yeah, so that's not really considered in this, to be honest. But this is like preparing you for coming out of the corner, I suppose. Yeah. When you go back on the throttle, you're in the right gear. So
because of the whole time of okay, now you jump out of the brakes, and should you be in the right gear, then I think this math is very valuable to be in third gear instead of fourth gear when you get off the brakes, right? So all good. So there's the poll. I'm going to close this in just a second, and let's end that polling, and let's take a look at it. And in polling and share the results. We talked about, many of you take a look at data at the end of the day. What do you look for? And the number one answer, looking for areas of improvement in a particular part of the track. It's kind of interesting that that is exactly what we were talking about today, finding spots on the track. And a lot, 74% of the people that responded to this poll look for areas of improvement in a particular part. There is part of this track, there's one corner, maybe it's this one right here that we're talking about here, that's kicking their butt, right? And they know it, and they can feel that in the car. So then they go back to the data and say, okay, what am I doing, and what can I do better to help me there? So that's kind of interesting. Second place on that, specific issues you want to understand either as a driver or inside the car, vehicle performance or driver performance, vehicle health being that third one that we talk a lot about here. And then the third place one is comparing my performance with the last time I was at the track, what their constant improvement, right? So that one, at 64% of people are going to go look at their data from qualifying to the race, or last race event to this one, and comparing them. And the rest of them were fairly small in numbers relative to those three. So kind of interesting data. I appreciate everybody doing the polls. It helps us when we are actually planning towards future webinars and guests and co-hosts and trying to understand these things. So I appreciate everybody that helps us out on those.
Can I ask a question? Like,
you sure can.
Back to the audience of people. It's like, on that 74%, there was like finding what was it, on a particular part of the track? I forget.
Looking for areas of improvement in a particular part of the track.
Yeah. So how do people define that? Is it that they don't know what to do, right? And I remember I'm a racer as well, right? So there's a particular corner here. I'm pointing at it, you can't see it, but and I race on this track, and I have no clue how to go around this corner. Okay.
Everything you have tried hasn't worked well, I take it.
Yeah, and you can see it in the data that I'm driving around, I have no clue. Like, I do it every time it's a new adventure, right? So is it that? Is it like you just don't have a plan? Or is it that you're just trying to, like, you're confused? And so what is it that
everybody that's listening to the question in the chat box, let's go throw some in there, and we will have we share our chat boxes with Samir when we're all done as well. So we'll I think most of the time it's you're racing, so you're around other cars and the feel, so you're out there, and number one, it doesn't feel well. Every time you come off the corner, you haven't used everything that you should use, or you're always understeering off because you're trying to ask too much of the corner corner exit or something, right? Or you're in the group, and every time coming off that corner, everybody yanks you, right? And so you know you're doing it wrong. It just now it's and gosh, I've tried earlier apexing. I've tried to go in slower and come out faster. I've tried these things, right, in a different gear, and it's not there. So we're looking for something, right? So interesting. I look forward to some of the questions.
Oh, okay. Yeah, I see. Yeah, when you listen to what other people say as well. Yeah, I'm just reading the chat here. Yeah. Because everyone goes through the corner flat, don't they? It's like, yeah, I did that flat. And you're like,
all of your racing friends, I'll tell you that turn one is flat. Yeah, gosh, be careful.
Of course they do.
they want to have an easy pass on you in turn one, obviously. So, but anyway, I appreciate everybody's chatting about things, and I appreciate Samir you coming in and talking about things like this. It's been very educational, I hope, for lots of other folks. It certainly was for me. I'm going to share back to the presentation as we kind of close this out for now, and let's go jump back in here. Come on, baby, there you go. The everybody also in the chat, if you think you'd like to have Samir come back and give us pick another topic that from an engineering standpoint, let us know. As soon as we get done with this, within an hour or two, we're going to have this one along with the other 116. This will be the 116th video we're going to stick up on our YouTube eTraining video site. It'll be up there just shortly, and all of the links we've talked about and some of the other things will be in the description box. So please, if we went over something a little too quick, we really do hustle these because we only have an hour, more or less. I always go just a tick long, but we go through it as fast as we can, knowing that you have the ability to go out and rewatch some of it later. Hopefully we've hit it all the right answers. So visit us out there at the YouTube site. That's where we house all of these for all of you to watch again later. Customer support, Samir, he has this website there. He's talking to people. It's a customer support company as well. We here at AIM, same thing. Boy, we're at tracks every weekend, answering the phones all during the week, emails, making sure that we help you get just as much value as you can out of these AIM devices. Love helping everybody. Give us a call. The 800 number there on the screen, or look for us in our vans or our backpacks out at the track local to you. So looking forward to that as well. Let's talk about the next webinar. The next webinar is one that I have been looking forward to. This is it's something that we've started to made available recently worldwide. It's been available, and we're going to bring in an expert on the subject, introducing the AIM Sports PDM. We're going to bring in Fabrizio Rizza from AIM Sports Italy. He's the hardware manager for AIM Sports. We've had Emiliano on here a number of times talking about Race Studio 3. A cohort of his, a co-worker at AIM Sportline in Italy is Fabrizio, and he's going to come on and he's going to chat to us about. We're going to start off a little slow like we did with Race Studio 3. We're going to talk about what is a PDM, why would you want to consider it, and we'll probably do 3 or 4 different ones in time, one a month maybe, or something, maybe a little bit faster than that. But we're going to talk about what is this thing and PDM. Some people understand the power distribution model, but the AIM PDM, it's more than just a power distribution module. So we're going to talk about that. It's a data logger. It's a bunch of things that is very, very, very powerful. And a lot of you guys have been talking about them and looking at them. We're going to bring on the person that knows the most about them and introduce it to you on Tuesday, September 22nd, coming up. And boy, we look forward to you being here with questions and comments and get it straight from the horse's mouth about different things, the reason it was designed in certain ways and what it can do. Looking forward to that a lot. So please make sure you join us next Tuesday for that. It's going to be a good time. So to kind of turn it back to this one and kind of close this out, Samir, I appreciate it. I know you, as well as everybody else in motorsports, super busy right now with our compressed season, and so I know there was a lot of work for you to put this together, and AIM and certainly all of our folks that attend these webinars. Really appreciate you coming on and sharing some knowledge. Hopefully we can get you back again and do some more. Anything else you'd like to add as we're kind of closing down here?
Well, no, just thank you very much for having me. It's a real pleasure. It's lovely to have the interaction with everyone else. If you do pop on my site, you'll see that most of the stuff I do is kind of one-way traffic. So this is lovely to have a little bit more stuff. It's like coaching, but to a whole load of people at the same time, and hopefully people found it useful. So yeah, thank you for having me.
Yeah, you're very welcome, and thank you for coming. Samir's contact information there, hello@yourdatadriven.com. If you want to get some more information, we've had the links in the chat box. The links will be in the description below for some of the couple of his processes that we've talked about. And Samir also does 3 or 4 different things on his website. One of them is podcasts that he brings in folks to talk about. And I have agreed that maybe in the next 3 or 4 weeks, or whenever we can all work it out, we're going to go and do an hour or whatever, and just talk about data in maybe a little less structured way. But we'll have a good time talking on his podcast too.
We want to talk about you, Roger. We want to talk about you.
Yeah, turn this around a little bit, right?
Yeah, totally.
Maybe I'm not so comfortable with that.
I'm not used to being this side of the mic.
Exactly.
I'm much happier interviewing other people.
Exactly.
And talking about them. I've had some amazing guests on
that might be you have, and I was just going to mention that if go to his website and click on the podcast button. There was 8 or 10 of them that you've already done something like that, and they're all very interesting. I've had a chance to listen to most of them, and I really have enjoyed it. So keep that in mind, everybody. I appreciate you all being here. Stay safe out there. Continue to look at your data and go fast, and look forward to seeing you all next Tuesday. Talk to you soon. Thanks again, Samir. Thanks to all of our AIM guys that were in the background answering questions. I appreciate that as well. Talk to everybody next Tuesday.